In this video, we're going to go over the graphs of y equals a sine x and y equals a cosine x. So before we get started, it's always good that we have a nice website that we can graph from. So that website I'm going to be using is desmos.com, and it's free. You can create an account if you want. You can download it onto your tablet or phone. It's always free. You'll never have to pay for anything with it, which is really nice. That's the first thing. Second thing is when we graph, we're going to be using radian measurements. All right, so for example, all right, in the x direction, we're going to be using values like 0, pi over 6, pi over 3, pi over 2, pi, 2 pi over 3, 5 pi over 6, 2 pi, etc. All right, so those are the x values we're going to use, and then depending upon which one of the functions or which one of the trigonometric functions we're using, sine or cosine, you would just substitute these values in, and then you would figure out their corresponding y values. Now, what's really nice about this is the fact that we can use Desmos to help us with all of this. All right, so let me go ahead and get that website out for us. And I'm going to change this just to y equals sine x. So initially, when you sign into Desmos, okay, it's going to look something like this. And I'm just going to give you a brief little tour of this. On the left-hand side is going to be where we input all of our functions. Lower left-hand corner is the keyboard icon where you have all these different buttons you can select. The functions themselves right here, sine, cosine, trig, tangent, all that. When you go ahead and you type something in, you would just use your keyboard like y equals sine x, and that's exactly what you get. It's extremely user friendly. On the left hand side, where it says number 1, this blue icon, if you left click and hold it in, you can change your line to, let's say you wanted a little bit bigger and you want it a little bit thicker. Maybe you want to make it dotted or dashed. I mean, whatever you want, you can do this. All right. So let me go back. Let me make this normal here. Make that 1. Let's make it 5. There we go. I like that more. Okay. You can also plot points if you wanted to, exactly just like how you would write it. So for example, if we wanted to plot the point 0, 0, you would plot it just like that. Notice in the origin, it's in green. What I'm going to do is I'll change that to like black. I can label it. I can even drag it if I want. So if I just grab the point, notice I can drag it and it changes the point for me. Very, like I said, very, very, very user-friendly stuff here. All right. Still on the left-hand side, across the top, this little gear icon, you can change this to a table. So let me do that again. So I'll click the gear icon. Notice the very first one is create a table. I can duplicate it. So if I want like another sine graph, I can click on that and I'll duplicate it. Doesn't matter, but we're going to create a table. And notice, here's the table that we were building earlier. But it's a little bit weird right now. And the reason why it's a little bit weird at the moment is because the values are whole numbers. Like they're integers. -2, -1, 0, 1, 2. So the question becomes, how can I get these to be radian? Well, it's actually very simple. Far right side, you have the gear icon. So we're gonna click on the settings, and right here where it says step, we're gonna click on that and then type in pi for pi. All right, and as soon as you do that and you hit enter, notice all of your values now on the x-axis are in pi. In fact, I can zoom in a little bit more. So here we have 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and so forth. So then we can come over to our table and we can just start typing in these values however we want. 0, pi over 6, pi over 3. Let's see. Let's do the other ones here. Pi over... Oh, well, no, we'll do 2 pi. Sorry. 2 pi over 3. And we'll do one more. 5 pi over 6. All right. And notice that they also put like little dots here for us at each one of those values that we wanted. Okay? So, like I said, Desmos extremely helpful for us. So now we can start diving into a little bit deeper into what these graphs actually look like. So for example, this is a standard sine curve. Y equals sine of x, okay? I'm going to copy and paste this into our notes because we're going to need it here. Because I want to talk a little bit about it. All right, so the first thing that we're going to look at here with our graph, and let me get out a blue marker so I can match it up here. Y equals sine of x is the fact that there's a number technically in front of our trig function, and that is the number 1. All right. So in fact, if you go back and you look at the heading of the section here, it's y equals a times the sine of x. All right. The letter a, which is the coefficient of our trig function, is called the amplitude. Now the amplitude is the measurement from the x-axis to either its peak or the measurement from the x-axis to what we call a trough. All right. So when we think about the amplitude, all right, so the number, which is the absolute value of a, because this is a distance. The amplitude measures the distance from the x-axis to the peak or the trough. And maybe I can write those here. Peak and trough. All right. So the number, which is the absolute value of a, is called the amplitude. Of the curve. All right. It represents the greatest y value in either y direction. So in this scenario here, our amplitude is going to be the number 1. So this distance right here is the absolute value of 1, which is equal to 1. In fact, you could just, if you go back, you can see that that is y equals 1. Okay? So this is the amplitude. Sine curves have different amplitudes all the time. So let's go back to Desmos and let's just see how that affects us. So let's get rid of that. Let's get rid of that. All right, so let's see. Let's do y equals, let's say, 4 sine x. Oops. Help if I can spell. All right. Let's get rid of this. So now you can see, although we still have the same exact x-intercepts. So we have an x-intercept at 0. We have one at pi. We have one at 2 pi. And we have the same exact maximum values. We have one at pi over 2 in blue, and then in red would be the same exact thing. It's still pi over 2. But notice that the amplitudes are different now. All right? So I guess in a electrical system, the sine curve in red would have more energy associated with it because the amplitude is higher. All right? Your thermostat inside your house works the same exact way as what's happening here in this graph. All right? So basically what happens with your thermostat in your house is we have time and we have temperature. Okay? Now, in the summer, humans tend to like it 72 degrees Fahrenheit. All right? So this is your target line for your thermostat. However, as the day progresses in the summer, your temperature in the house, it goes up and it goes down and goes up and goes down. When you reach this maximum peak, in other words, when the amplitude is higher than 1 degree Fahrenheit, or better, we'll say 2 degrees Fahrenheit. All right. What happens is your air conditioner turns on and it starts to drop the temperature inside your house, lower and lower and lower. It reaches 72, and then it tries to maintain 72 degrees for a certain amount of time. If it can reach that certain amount of time, it turns the air conditioner off. But sometimes it cools down so quickly that it gets below. And that's okay. Now the temperature comes back up, goes all the way back up to this maximum. 2 degrees Fahrenheit over. Then the thermostat tells the air conditioner, hey, turn on again and turn down. So whenever you have this oscillation going up and down, this is called a sinusoidal curve. And all that means is it goes up and down, up and down. And sorry, I misspelled sinusoidal. There's no U at the very end. So it is SINUSOIDAL. So the next curve we're going to talk about is y equals a cosine x. Now, cosine x and sine x are very similar, except, cosine starts at 1 and just follows the same sinusoidal curve. But like I said, it goes through 0, 1 for a maximum, or 0, -1 for a minimum. And it just keeps going back and forth, up and down, just like that. So if we go back into Desmos here, in blue, I have our cosine curve. And if I just turn on the sine curve right here, you can see how they kind of just mimic each other. Let me change this to orange. There we go. So like I said, you can see how they kind of mimic each other a little bit. But the main difference here is in orange, which is our sine curve, it goes through the origin. And in blue, which is our cosine curve, it goes through the y-intercept of 0, 1. However, everything's the exact same, meaning it still oscillates, and the number out in front is still going to be our amplitude. And with that being said, I'm going to end this video on here. Very straightforward. The homework's very straightforward. Just make sure you are using Desmos to really help you out with all this. Because like I said, Desmos really helps. So remember, create your table using this edit list. You can come into the edit list right here, and you can type in any value you want. So if you want pi over 2, pi over 2. And I'll tell you exactly where it is. And you can go ahead and plot it if you want. It's right here, pi over 2, 0. So everything's listed there for you. The only thing you got to do is just use it. See you in the next video. Create your